So for this demo, I'm going to walk you through the different model-assisted labeling tools that we have in the platform. These tools are powered by computer vision models and help you annotate your data much faster. And so for that, I set up this use case where we want to segment nucleus in these images. And the first tool that I'm going to show you is this tool that already James showed you really quickly, which is called Auto-Annotate. So this is a class-agnostic annotation tool that, given a bounding box, you select it here in the platform. It's the generic Auto-Annotate. So given a bounding box, it will segment the object that it's inside this bounding box, or the most likely object that the tool thinks that you want to segment. So for example, if you draw this bounding box, you have to select what class are you segmenting here. That's why it's class agnostic, and it will produce a mask of the object inside. You can keep annotating examples like this, but it also works. It has never been training for segmenting nucleus. So it's a pretty generic object segmentation tool. So you can, for example, run it in different objects. You want to segment this. You can even correct it. This part is missing, so you can add it and make corrections or removing parts. Let's say if it, let's segment it in this larger region here and making this mistake, and then you can correct it. So this actually produces quite good results, but it can be cases where this is not as precise as your task needs because it's not specific for a given class. So to address this, we also provide ways of using your own models, either models that you have trained within the platform or models that you have trained on your servers, and then you can also sit here. So then let me show you how this will work. So for this, you will go to the models. These are, for example, imagine that the use case where you have already annotated some data, and then you can use this data to train a model that then they will help you training the rest of your data faster. So for that, you can launch. Let me first start a model. These are models that I already trained for this demo. So let me start it first, and I will show you how you can use it for assisted labeling. So what I was discussing is that once you have your data, you can launch a training within the platform. So for example, we want to train an instance segmentation model on the data that I already annotated. So this nucleus segmentation training, and then this will launch a training. So as soon as this finishes, you will have it available for annotation. Same thing, you can, if you have your own model, you can also register. So you can, there is a tutorial that we have in our blog. If you click here, it will show you the process that you have to follow to bring your own model. So any model that you might have trained on your own data externally, or even a public model that you want to use as a tool, you can import it into Darwin. So once this is starting now, it should start real quick. But let's go back to the data set. 1 second, it's still starting. Should have started a bit before. Let's go back again to the data set. Okay, so let's take this image, for example, and then, okay, we have it here. You saw before that we only had one. Now that this one has started, you can select it from the tool. So this model has been trained to segment all these nucleus already. So whenever you draw also a bounding box, it will run inference on this part of the image. You can do it for several. You can do it in different areas, more like, let's say this would what an annotator would do manually here in the work view. Let's try a different example. For example, this one is too dark, we won't see. Okay, so not only you can use it in this way in the work view, so in this UI, another advantage of having this model is that you can also run it in a workflow. One of the workflows that James just showed you how they work, you can, let's go to workflow here. This will be the typical workflow where you have your data set that you send to the annotators, and then this goes through the review and it's marked as completed. So we can replace the annotator with a model stage. So the data will go through the model. The output of the model will go to review. We need to connect a model. So we connect the model that we just started. And then typically, in case the reviewer is rejected, you would send this through an annotator that will correct whatever mistake or error that the model could have made, and this will go to review. This is a typical workflow that you can use whenever you have a model for this. So we know that some of the challenges that we typically have with this kind of data is having really large images, and this is always challenging either for training models, because inputting these kind of really high resolution images to model some cases you have to rescale so you lose a lot of information, or you don't have enough RAM or memory to actually run these models. And the same happens for inference, so you cannot do, let's say, an inference call to a model whenever you have like these gigabytes of size images. So for that, we also provide a couple of workarounds for this. One option that we have here is we have a tutorial here, and we will share this tutorial how this works. But the idea is that you can segment. There is a workflow that you can set up, and we explain it here in one of our playbooks in our website. Is that you can use these workflows to split large images into patches. So setting up this workflow, I set up this as an example, but it is that you can connect a data set, and then you will draw bounding boxes in this data set, and this webhook, what we'll do is cropping all these boxes into patches. So then in this case, we are converting a data set of WSI images, of whole scale whole slide images into patches. So this is something that I ran already before, and then importing from this other data set, we are importing here all different patches. So now in this data set with the patches, we can already use it for inference or for training. And another solution that we also offer is that you can import your own annotations made outside of V7. So let's say you have a model, and you have in your own servers a way to run inference through these models. You can generate all these annotations, and then you can import them into Darwin. And then these annotations, you can use them for review. So you will use also the typical workflow of you have the annotations, and then you send them through an annotator that will correct them, and then send through the review, and then mark as complete, or back again to review.